Hi guys, welcome to Brilliant Katha JEE Mantra Series Chemistry Part Test 6 Recap video. In this video, mainly going to discuss about the chapters Chemical Bonding, Molecular Structure and Redox Reaction. You know, these two topics, especially chemical bonding and molecular structure, that's a very important topic. If you learn that topic, means you can answer many kind of questions, okay? That this topic is actually the basic backbone of many chapters. And redox reactions, you can get maximum one question. That also will be very easy question. Easily you can get one question from this chapter. Redox reaction. So let's look about the important points we must have to cover, okay? So first of all, we are looking about chemical bonding and molecular structure. As we know, the important concepts we have to go through is octet rule. What is octet rule? What is demerits of octet rule? What is VSCPR theory? What is valence bond theory? In valence bond theory itself, orbital overlapping concept, hybridization concept, okay? Then molecular orbital theory. Then what is dipole moment? Resonance, ionic bond, about ionic bond, Fajans rule. That much idea we have to cover. In that itself, first of all, we must have to look about what? Demerits of octet rule. Octet rule, as we know, what? Every atoms are trying to attain 8 electrons in their valence shell. For that purpose, they will either lose electron or they will gain electron or else they will share electron. So that is what is ionic bond formation, covalent bond formation, coordinate bond formation. That idea you learned. So even though there are a lot of failures are there in the octet rule, like what? Like we learned, it could not explain about the superoctet molecule like H2SO4 as well as SF6 as well as PCl5 etc. That it couldn't explain. And the second thing is it couldn't explain about what? Odd electron containing molecule like NO, NO2, like that molecule, that their central atom contain odd number of electron. Its stability also it couldn't explain. As well as its main problem is it couldn't explain about the electron deficient molecule. That means some molecules in their case, example BF3 and all, in their cases BF3, if you are taking BF3 around boron, only 6 electrons are there, only 6 electrons, 6 electrons are there around it. Its stability cannot be explained by using which theory? This octet rule. Like not only BF3, the 13th group forming compound BeCl2, beryllium chloride. Okay, you remember that? Yeah, that all are the idea it couldn't explain. As well as this, mainly the octet rule, okay, Coastal and Lewis, they mainly focused about this octet rule. Mainly they compare with noble gases, inert gases. But that inert gas itself, example xenon itself is forming compound like XeF2, XeF4, XeF6, XeOF4, okay, XeO3, so many compounds this xenon is forming. That also it couldn't explain. As well as the main another problem of this octet rule is actually it couldn't explain about the shape of the molecule. Like that, a lot of problems are there. Correct? That idea you have to go through it. What is superoctet? That means expanded octet. What is electron deficient? Like that question may come. Ready? Yeah. Then after that, dears, we have to go to what? We have to learn about the VSCPR theory. Actually, it is actually trying to explain about the shape of the molecule. Valence shell electron pair repulsion theory. 4 postulates are there that you have to remember, that you have to keep it in mind. What? The shape of a molecule depends on the number of valence shell electron pairs. Valence shell electron pairs means VSCP. That is nothing. That's actually the sum of bond pair plus lone pair. That idea also we know. Bond pair plus lone pair. For example, NH3 if we are taking, this is NH3, this is NH3. Here bond pairs is 1, 2, 3. 3 bond pairs are there, lone pair equal to 1. So total VSCP equal to how much? VSCP equal to 4. That idea we know. Ready, dears? Yeah. Next step is actually, next statement is this valence shell electron pairs repel each other. This bond pair, lone pair, they will repel each other. To avoid repulsion, they will arrange maximum away from each other. Okay, and then again the order of repulsion is lone pair repulsion is always greater than lone pair repulsion than bond pair repulsion. Bond pair repulsion is lesser than lone pair and lone pair. As well as all multiple bonds are treated as what? Single bond pair. For example, if we are taking CO2, We have to count the bond pair, not 1, 2, 3, 4. Not like that. This double bond we will consider as 1. 1 bond pair, 2 bond pair, 2 bond pair. Like that we have to consider. So if there is a double bond or triple bond is there, means that we will treat it as single bond. This is actually the VSEPR theory. By using that, we must have to remember about the shape of the molecule. Like if 2 bond pair, no lone pair means its shape is linear, as well as 3 bond pair, 0 lone pair means trigonal planar, 4 bond pair, 0 lone pair means tetrahedral, and 5 bond pair, 0 lone pair means trigonal bipyramidal, 6 bond pair, 0 lone pair means octahedral. That idea we must have to remember. Bond pair, lone pair, that this many bond pair, this many lone pair, this will be the shape. That idea we must have to know. And if lone pair comes means, 2 bond pair, 1 lone pair means we are expecting trigonal planar shape, but because of the lone pair, it will be forming bend shape. That idea we must have to keep. Next again, 3 bond pair, 1 lone pair means we are expecting tetrahedral, but because of the lone pair, it will attain a shape of trigonal pyramidal. Okay, and 2 bond pair, 2 lone pair, we are expecting total VSEP is 4, tetrahedral we are expecting, but we will get again bend shape. And 4 bond pair, 1 lone pair, we are expecting trigonal bipyramidal, but we will be having a seesaw shape. So you have to remember 4 bond pair, 1 lone pair, seesaw shape. That idea you have to keep it in mind. Next 3 bond pair, 2 lone pair means T shape. Next 5 bond pair, 1 lone pair means square pyramidal shape. And 4 bond pair, 2 lone pair means square planar shape. And again, 4 bond pair, 1 lone pair means again what? Bend shape. See, bonding base 4 lone pair. That here actually not 2 bond pair, 1 lone pair means bend shape. 3 bond pair, this is not 4, this is actually 2. I'm sorry, here it is 2. Okay, 2 bond pair, 1 lone pair means that's also bend shape. 3 bond pair, 1 bond pair means 3 bond pair, 1 lone pair means trigonal pyramidal shape. 2 bond pair, 2 lone pair means bend shape. 4 bond pair, 1 lone pair means seesaw shape. How they are arranging that also here in the, you can check it in the NCERT, it is directly there. Okay, the same thing only I included here. Okay, yeah. Next again, 3 bond pair, 2 lone pair, T shape. Similarly, 2 bond pair, see, 2 bond pair, 3 lone pair comes means 3 bond pair, 3 lone pair comes means like this. Oh, see, AB2, E3. Like that comes means A will be there. Around it, 2 bond pairs will be there and 3 lone pairs will be there. See, 3 lone pairs will be there. That is having what shape? Linear shape. This much idea you must have to keep it in your mind. Ready? Yeah, clear. So that bond pair, lone pair, 4 bond pair, 1 lone pair comes means seesaw shape. 3 bond pair, 2 lone pair comes means they are forming bend T shape. That idea you have to keep it in mind. Then you can easily calculate any shape. You can calculate any bond pair. They will give you the examples. Then they will ask you about the shape. They will ask you about the bond pair, lone pair. That's a repeatedly asking questions that we can solve by using a simple technique that I am going to teach you. Listen to me very carefully. If you know bond pair, this many bond pair, this many lone pair, and this is the shape means I'm going to help you how to calculate that bond pair and lone pair. Any molecule if they give means you can use my formula. This is the formula we are going to use. Total valence electron divided by 8. Total valence electron you have to calculate, divide by 8. If you calculate means you will get what? You will get the idea about bond pair and lone pair. Let me show you one example. If you are taking XeF2, xenon difluoride, if you are taking, see, here you can see, xenon belongs to 18th group, its valence electron. In valence shell, 8 electrons are there, okay, plus fluorine. Fluorine belongs to 17th group, or else fluorine atomic number is 9. Electronic configuration 2, 7. So valence electron 7. Like that, how many fluorine are there? 2 fluorine. So into 2. Clear? So 8 plus 7 into 2 means 14. That means 22 valence electrons are there. So 22 divided by 8 if I am doing, you can see that 22 divided by 8 means 2 8s are 16. Remaining is how much? Remaining is 6. The answer you are getting here, that is what is actually the number of bond pairs. And the remainder you are getting here, that you have to make it to pair. 6 means how many pair? 3 pair. So 3 lone pair. Okay, 2 bond pair, 3 lone pair means you know the idea, that is actually linear shape. Likewise you have to tell. Clear? Pakka? Sure. Then see one more example. Let me show you. SF4. SF4. Sulfur. Sulfur belongs to 16th group. So valence electron is 6. 6. Fluorine. Fluorine means 7 into 4. Okay, so 6 plus 7 into 4 is 28. So total 34. 34 divided by 8. 34 divided by 8 means what I can do? I can divide 4 8s are 32. Remainder is 2. Answer is bond pair. And the remainder we have to make it as pair. That is 1 lone pair, 4 bond pair. 4 bond pair, 1 lone pair. That means seesaw shape. Clear? So now we are getting bond pair, lone pair idea. Then we can tell about the shape. Seesaw shape. That will be seesaw shape. Okay. Clear? This way we can calculate. And here one exception you have to think. Hydrogen. If you are using my formula, then hydrogen you have to take valence electron is 7. Because we are considering everyone are obeying octet rule. Like that we are considering. Clear? You have to keep it as an exception you have to keep. Hydrogen is 7. For example, NH. NH4 plus if I am taking. What is the shape? What's the shape? Nitrogen belongs to 15th group. Valence electron is 5. Plus hydrogen, we don't want to take 1. We have to take how much? 7. If you are using my formula, you have to use 7. Okay. So 7 into 4. What do you mean by this plus? Plus means 1 electron is missing. So minus 1. If it is minus here means we have to add 1 electron. Clear? So 5 plus 7 into 4 means 28 minus 1. So that means 33 minus 1 equal to 32. 32 divided by 8 means 4 bond pair, 0 lone pair. So the shape is what? Tetrahedral shape. That way we can remember. Clear, dears? Yes or no? Yeah, this is the idea about the calculation of bond pair, lone pair. If you know the bond pair, lone pair, you can tell about the shape. Ready? Yeah, we can go to the next idea. That is what is valence bond theory. In valence bond theory, overlapping occurs. They are explaining about the overlapping of atomic orbital. The bonding is because of the overlapping. Okay. The bonding between two atoms mainly because of the covalent bond is mainly because of the orbital overlapping. Okay. See, that overlapping occurs between half-filled valence shell orbitals of two atoms. Half-filled valence shell orbitals of two atoms. Okay, that resulting bond acquired a pair of electron with opposite spins to get stability. One will be clockwise, one will be anti-clockwise. They will overlap during that time. Then they will get stability. Okay. Third point, orbitals come closest to each other from the direction in which there is a maximum overlapping. On that basis, two kinds of overlapping are there. End to end is sigma, sidewise is pi. That idea also you know, you remember. Okay. Next, covalent bond has directional character. Yes, of course, they are coming in. If they are coming end to end means sigma. They are coming sidewise means what? Pi. So, of course, they have what? They have directional character. But ionic bond have no directional character. Extent of overlapping is directly proportional to what? Strength of covalent bond. That idea also you have to remember. Especially the overlapping. Whenever we are considering the overlapping, the one with the molecules with the directional character. I mean the orbitals with the directional character like P. So PP overlapping is more powerful than SP overlapping than SS overlapping. Directional orbital have more overlapping than non-directional. S have no directional. P have direction. Px, Py, Pz is possible. Dxy, Dxz, D is directional. S is the one and only one non-directional orbital. Okay, so directional orbital overlapping is more powerful than non-directional than non-directional. That idea you have to keep it in mind. Clear, dears? Yes. Next again, we can look about hybridization. Hybridization is the intermixing of atomic orbitals and forming a new orbital. They are having equal energy, same sizes, shape and energy. That orbitals, okay. So during the hybridization, we must have to know only orbitals of almost similar energy belongs to the same atom or ion undergo hybridization. Same atoms, same energy, comparable energy orbital only will undergo intermixing. Second one, the number of hybrid orbitals produced is equal to the number of pure orbital mixed during hybridization. 1s, 3p you are mixing, total 4 orbitals you are taking means 4 sp3 hybridized orbitals will form. That idea. Okay, clear. Next, hybridization of orbitals only takes place. Orbitals only takes place, not electrons. Hence, half-filled orbital, fully filled orbital and empty orbitals of equivalent energy may involve in hybridization. Statements are important because sometimes they will ask about assertion, reason or else what? That which statements is correct, which statement is wrong, like that they can ask. Clear? Yeah. Next again, most hybrid orbitals are similar shape, size and energy. Yes, that we know. Orbitals involved in pi bond formation do not participate in hybridization. That also very important. Okay, ready. So if we know about the hybridization concept means we can find out. They will ask about the molecule they will give, then they will ask about what? Hybridization. They will ask about hybridization. Like that, you have to remember one more thing. Hybrid orbitals are distributed in space as apart as possible, resulting in a definite geometry of molecule. That hybrid orbital they are forming, they will arrange maximum away from each other. There only other atoms, atomic orbitals will come and overlap. Because hybrid orbital overlapping is more powerful than hybrid orbital, atomic orbital, than atomic orbital, atomic orbital. So instead of directly to atomic orbital coming and overlapping, before that they will undergo intermixing, they will form hybrid orbital. This hybrid orbital will form what? Overlapping. That is what is hybridization. So if it is sp hybridization means they will give what? Linear shape. If it is sp2 means trigonal planar. If it is sp3 means tetrahedral. If it is sp3d means trigonal bipyramidal. If it is sp3d2 means octahedral. Here you just remember about one more idea. Let me tell. If VSEP2 means sp. If VSEP3 means sp2. If VSEP4 means sp3. If VSEP5 means sp3d. If VSEP6 means sp3d2. Nothing. S1 P3 D2. You know how to add. 1S 3P 2D. I am adding means how much I will get. 6 I am getting. So 6 should be the VSCP. And if SP means 1 1. So 1 1 if I am adding means 2. So 2 will be the VSCP. If you know the VSCP means we can tell about what? The hybridization. Let me show you one example. We did already before. XCF2. If they ask about the hybridization, how we will do? The same formula what I taught you, you can apply here. What's the formula I taught you? Total valence electron divided by 8. The same formula you can apply here, dears. Total valence electron by 8. So here xenon, that belongs to 18th group. So 8 valence electrons are there. Fluorine belongs to 17th group. So 7 valence electrons are there into 2. So 8 plus, okay, 8 plus 7 into 2 means 14. 14 plus 8 means 22. So 22 divided by 8. See, 22 divided by 8. Once I am dividing, 22 divided by 8 means 2 8s are 16. Remainder is 6. So that means 6. Here the answer is bond pair. Here the answer we have to make it as pair. 3 lone pair. 2 bond pair, 3 lone pair. VSCP. VSCP means what? Bond pair plus lone pair. Bond pair plus lone pair. 2 plus 3, 5. 5 comes means what's hybridization? 1S, 3P and 1D. sp3d. Like that you can tell. So if you know bond pair, lone pair means you have to add it. That is VSCP. If VSCP2 means SP. VSCP3 means SP2. VSCP4 means SP3. VSCP5 means SP3D. VSCP6 means SP3D2. Simple. Will you do it? Yes, I know you will do it. Okay. See, we can go to the next idea. That is what is molecular orbital theory. Here the same like atomic orbital, molecular orbitals are there. Their formation is different. They are actually forming because of the linear combination of atomic orbital. That basic theories you have to go through. Okay, so we can look about the important idea here. That is actually how the electrons are filling in molecular orbital. The same rules what you learn for Aufbau principle as well as what Aufbau principle, Hund's rule, Police-Exclusion principle, all is applicable here also. The molecular orbital they are combining together. They are undergoing linear combination. You will get a new orbital. That is what is called bonding molecular orbital as well as anti-bonding molecular orbitals are there. If they are adding means bonding molecular orbital. If they are subtracting means anti-bonding molecular orbital. That idea you must have to know. Here once you are looking up to 14 electron, this is the order. Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2px equal to pi 2py, then sigma. First pi bond will form, then after only sigma bond will form, then pi star 2p. Here in molecular orbital theory, according to valence bond theory, first sigma will form, then only pi will form. So according to molecular orbital theory, pi bond can form first, then sigma can form. Then pi star 2px, pi star 2py, sigma star 2pz. And more than 14 means here the problem. First sigma will form, then only pi will form. That idea you have to keep it in mind. You know how to fill the electron. Next from there they can ask about bond order. Bond order equal to half into NB minus NA. as well as this bond order is directly proportional to bond strength and directly proportional to bond energy, inversely proportional to bond length. But once they are asking the question regarding bond order means you have to remember only this structure. This is enough. If you know how to calculate the number of electrons, then easily you can find out the bond order. Only you have to remember this one. Maximum bond order is 3. Maximum bond order is 3. That is for 14 electron. 14 electrons are coming means bond order is 3. Then here I am writing 15 electron, 16 electron, 17 electron, 18 electron. Here I am writing 13 electron, 12 electron, 11 electron, 10 electron. Now what you want to do now, if you want to find out the bond order means 14 means 3. Then 15 means 0.5 you have to decrease, 2.5. Okay, 16 means 2. This one 1.5, this one 1. And here 13 electron means 2.5. Then here 2. This is what? 11 electron means 1.5, 10 electron means 1. Now if you remember this one means easily you can remember. If you remember this one means we can find out the bond order of carbon monoxide. What is the bond order of carbon monoxide? See, carbon contains 6 electron, atomic number. Oxygen contains 8 electron. So total 14 electrons are there. 14 electron means bond order is 3. Simple. If they are asking about O2 2 plus, O2 2 minus. See, O2 means oxygen atomic number is 8. 2 8s are 16. And plus 2 minus means 2 more electron, 18 electron. 18 electron comes means bond order is 1. Like that you can tell. And as well as if they are asking about the magnetic behavior, you have to remember odd number containing species. Odd number electron containing species are always paramagnetic. Paramagnetic. Okay. As well as even number electron containing species. Even number electron containing species are diamagnetic. Diamagnetic. That idea you have to keep it in mind. Exception is there. Odd number electron containing species plus 10 and 16. 10 and 16 is even though they are paramagnetic. Once you are filling that electron, 10 and 16 have unpaired electron. That's why they are paramagnetic. So paramagnetic means what? Odd number containing electron as well as 10 and 16. Even number containing electron except 10 and 16 are what? Diamagnetic. For example, if they are asking about N2 minus, will it be diamagnetic or paramagnetic? How we can calculate? See, N2 means nitrogen contains 7 electrons. 7 into 2 means 14. And minus means 1 more. So total 15 electron. 15 electron is a odd. Odd means paramagnetic. Finish. What about O2? O2 means 16 electron. 16 is even, but it's an exception. It is also paramagnetic. Clear? So like that you can find out. Easily you can find out the ideas from their area. Clear? Yeah. That's all about the bond, molecular orbital theory. Next, we have to look about what? Dipole moment. Dipole moment is the product of any one of the charge in the intermolecular distance between them. This is actually used to calculate the ionic character in covalent bond. Okay, polarity in covalent bond. Here Q is charge, the order of 10 raised to minus 10 ESU, electrostatic unit, or 10 raised to minus 19 coulomb. Okay, D equal to intermolecular distance in the order of 10 raised to minus 8 centimeter or 10 raised to minus 10 meter. So that means mu equal to 10 raised to minus 10 into 10 raised to minus 8. That means 10 raised to minus 18 ESU centimeter. That is what's called 1 D by. Okay, D by is the CGS unit. So here 1 D by equal to what? 3.33 into 10 raised to minus 30 coulomb meter. That idea you have to keep it in mind. If you know the dipole moment means you can find out percentage ionic character is equal to observed dipole moment. Okay, observed dipole moment divided by dipole moment considering 100% ionic character into 100. Like that related questions will be there. As well as they will ask about the dipole moment. They will ask about whether the polarity, whether the in molecule have polarity or not, like that. If the molecule have a symmetry, dipole moment will be 0. That idea you have to keep it in mind. So see, here C double bond O. See, here in this case, this oxygen will withdraw the electron towards it. This oxygen will withdraw the electron towards its dipole moment. Net dipole moment equal to 0. BF3, see, look at here, BF3. This have symmetry. This have symmetry. This fluorine will take the electron towards it. This fluorine will take the electron towards it. This fluorine will take the electron towards it. This one 1 and 2. Their resultant will be in this direction. This one as well as this one will cancel. So mu resultant equal to 0. I mean, if there is no lone pair means, their dipole moment will be 0. That related questions you have to practice. Okay, dears? Yeah. See. Next one, Next idea we have to look about what? Fajan's rule. Okay, Fajan's rule. Fajan's rule is just opposite to that of what? Dipole moment. Dipole moment means calculation of polarity in what? Ionic compound. Sorry, covalent compound. Similarly, this Fajan's rule is actually covalent character in ionic compound. So how this ionic in ionic compound, how the covalent character arises whenever you are having a cation, okay, that is moving towards an anion. Anion means around anion that electron waves are symmetrically distributed. Whenever this cation is moving near to that means that anion electron wave, that electron wave will be distorted towards the cation. Now in between A and B electron waves comes. That is what is called polarization. That only I wrote here. When a cation approaches an anion, the electron cloud of the anion is attracted towards what? Forward towards the cation and hence get distorted. The effect is called what? Polarization. If polarization is more means covalent character is more. So for that the Fajans actually explained about like what? Fajans explained like what? More the charge of cation increases. Charge of cation increases. See? Charge of cation increases, covalent character increases. Charge of anion increases, polarization increases. Charge of anion increases, polarization increases. That means charge increases, polarization increases, covalent character increases. And charge of cation increases means instead of that we can tell what? Size of cation decreases. Size of cation decreases, polarization increases, covalent character increases. Charge of anion increases means instead of that we can tell size of anion increases. Like that we can tell. That related questions will be there. You have to calculate. They will ask about which molecule have more covalent character, which molecule have less covalent character. Like that they will ask. Okay. See. Next chapter we have to discuss is redox reaction. In redox reaction, mainly 4 topics we have to learn. First one, oxidation number calculation. That basic ideas you know. Okay. The second thing is different types of redox reactions and balancing of redox reaction related problem and equivalent weight related problem. So here, first of all, we are looking about different types of redox reactions. First one is combination redox reaction. Here, 2 or more substances combines together to give compounds. Okay. Here, if it is a combination redox reaction means at least one of the reactants should be in elemental state. Okay, yeah. And decomposition redox reaction means it is just opposite to that of what? Combination redox reaction. Here, one compound, okay, that will decompose to give more than one substances. In that, out of that, one of the products should be in elemental state. That's the condition. If it is a redox reaction, all decomposition reactions are not redox reaction. For example, calcium carbonate. Calcium carbonate, once we are heating, it will be giving what? Calcium oxide plus carbon dioxide. It is a decomposition reaction, but it is not decomposition redox reaction because there is no change in oxidation number. Here oxidation state of calcium is +2, oxygen is -2, carbon is +4. Here oxygen is -2, calcium is +2, oxygen is -2, carbon is +4. There is no change. So that is what is actually what? Decomposition redox reaction. Then again, displacement redox reaction means here when a compound, one element can be displaced by another element. It may be either metal, then it is called metal displacement, or else it may be the non-metal hydrogen, then that's what's called what? Non-metal displacement. That idea also you know. Then disproportionation redox reaction means when same element undergo oxidation as well as reduction, that is what is called a disproportionation. For example, H2O2, oxidation number is -1. Whenever they undergo reaction means that will become H2O. Here oxygen oxidation state is -2. Here oxygen oxidation state is 0. -1 become -2 means decreases. Decreases means what? Reduction. And -1 becomes 0 means what? Oxidation. So same element undergo oxidation reduction. Same element undergo increase as well as decrease. That is what is called disproportionation. So for disproportionation, if any compound show disproportionation means their oxidation number should not be the maximum, should not be the minimum. That idea you have to keep it in mind. Okay. See, next one. Proportionation. It is just opposite to that of disproportionation. Here same element with the 2 different oxidation state comes to same oxidation state. For example, whenever you are looking NH4NO2, this one undergo proportionation into N2 plus 2H2O. See, here the oxidation state of nitrogen in the first NH4, here it is -3 and here it is +3. And after the reaction, nitrogen oxidation state is 0. So -3, same element with the 2 different oxidation state comes to one oxidation state. That is what is called what? Proportionation. Clear? Yeah. Next one, again here you have to remember about what? Equivalent weight. Equivalent weight is equal to molar mass divided by n factor. N factor equal to number of moles of electron gained or lost by one molecule. That is what is equivalent weight. For example, KMnO4. KMnO4 in acidic medium, it will be forming what? It will be becoming Mn2 plus ion. So here manganese oxidation state is +7. It become 2 plus means what is actually happening? 5 moles of electrons are participating. So equivalent weight of KMnO4 is equal to molar mass of KMnO4 divided by 5. Like that you have to keep it in mind. Idea clear? So that per molecule how many electrons are participated. That idea is called what? Equivalent weight. So and also you have to go through what? Balancing directly from the option. You can substitute like that, you can find out, and that's all. And before that you have to remember about what? Oxidation number. That idea, an element can show maximum oxidation number is equal to plus group number, minimum oxidation state is equal to group number minus 8. That and all rules. Then some oxidation state finding rules. That all you know that I know. You know that that's the basic ideas. That related questions, maximum question you practice and try to write the next exam in a careful way. Part 6 should be in a careful way. Wherever you are feeling difficulties, that difficulty area you have to mention in the comment box. That particular area related video we will do it. So dears, all the best dears, do your maximum, do your best. Okay, so see you in the next video. Thank you so much.